In this lesson, we're going to be talking about topic 4.1, which is factoring trinomials with difference of squares and greatest common factor. So your essential question is, how do I factor an expression and how do I solve a quadratic equation using factoring? And your I can statements are I can determine the type of factoring I need to use to factor an expression, and I can solve a quadratic equation by factoring. So we're going to start with a pattern that we use to help us factor trinomials with no leading coefficient. So you may have seen this before. You probably did somewhere along the lines, maybe in Algebra 1, but not all teachers call it the same thing. So the way that what I call this is I call this the magic X. And there's not really a whole lot of magic to it. A magic X means what we're going to do is we're going to put whatever goes up here, we'll multiply to this number and add to this number. So that's how we're going to use this tool to help us factor our trinomials. So I'm going to start with my magic X. So I have a trinomial. I see it's quadratic because it's squared. Remember, trinomial means I have 3 terms. So I need 2 numbers that multiply to this last number, which is 20. And I need those 2 numbers to also add to this middle number that's 9. So we're going to multiply to 20 and add to 9. So 2 numbers, so I would go through the factors of 20. I'm going to try 2 and 10. 2 and 10 definitely don't add to 9. They do multiply to 20, so I'm not going to use 2 and 10. Another set I have is 4 and 5. 4 and 5 both multiply to 20, but they do not add to negative 9. However, if I were to put a negative sign in front of each of them, they now both add to 20 and or multiply to positive 20 and add to negative 9. So we cannot leave this on the magic X. The way we would write this is that it equals x minus 5 times x minus 4. If I wanted to check this, I could FOIL that out. I'm going to FOIL this one out only to prove it to you. I'm not going to FOIL any of the rest of them. So x times x would be x squared. X times negative 4 would be negative 4x. Negative 5 times x would be negative 5x. And negative 5 times negative 4 would be positive 20x. So we would have x squared minus 9x plus 20, which was our original. All right, I'm going to try this again. So in example 2, I'm going to try to find 2 numbers that multiply to negative 12 and add to 3. So I'm going to try my possibilities. I have 3 and 4. If I make one of them negative, doesn't matter which one, they're not going to add to 3. So I'm going to try something else. I'm going to try 6 and 2. 6 and 2 both multiply to 12, but I don't see even making one of them negative somehow that either one of them add to 3. My only other possibility is 1 and 12. 1 and 12 definitely multiply to negative 12 because I can make one of them negative, but none of them are going to multiply or add up to 3. So in this case, and this will not happen on every problem, it's very rare actually, we would say that this is not factorable. All right, let's take a look at example 3. So I need 2 numbers that multiply to 48 and add to 14. So as I'm going through my list, I'm thinking maybe 6 and 8. Let's see, 6 times 8 is 48 and 6 plus 8 is 14. So that has to be what it is. So I'm going to have x plus 6 times x plus 8. It does not matter what order the factors I have it. I could have written it as x plus 8 times x plus 6 as well.